So today on Scares and Sparks I'm going to show you the world's first, drum roll please, pop-up spring-loaded prop that doesn't suck. Blew her head off. This is video part 4 for the prop mechanism. I'm going to talk today about the software that goes into the little Arduino to make the magic work. Okay, so it's time to start looking at the software. If you've built it the same way I've built it with the prop controller board, you're going to have the same setup. This is the start of the code, and I've just got a big comment section here. It tells you what it actually interfaces to, and then it even tells you which pins different functions go on. So for example, D9 has the ratchet servo on, D8 has the jump servo, that's the release servo. Getting into the proper code itself, we've got a software serial library and the 𝗣𝗏𝗖 mini libraries, and these are what are being called up here and here. And then we're also including the servo library, which allows us to talk to servos. Now, the pinout is the same as the drawing above. So we've got a lights enable that just turns on a MOSFET to turn on some 12-volt lights. There's a limit switch, that's the thing at the bottom of the travel that will close when the central pillar comes down to the bottom. We've got the pin with the PIR trigger on, and then we have a couple of we have the music player, then software serial, which is declared as DF player. Then we have two servos, the ratchet servo and the jump servo, and we've given them different names so we can talk to them differently. A couple of different pointers here. The sound file is basically the pointer to which sound is going to be played, and the file count tells it how many files there actually are on there. So we're going to be using potentially 3 files. I think actually in this example I only use 1. And then we have the section where you need to start making edits. So these, when we did the initial servo testing and we noticed the different degrees of movement for the servos, those are the numbers you will hopefully have written down and you plug in here. So if you cast your mind back, turning the servo ratchet all the way back was 90 and moving it forward was 140. And if you remember, if I rattle between these over and over again, it made the ratchet move. Now, if we also, when we release the actual mechanism at the end, we want to move it right out of the way. So I've got this value called servo-rat-out-of-the-way, and I put that at 70, so that moves the arm completely out of the way to allow the ratchet to spin. We did the same trick with the jump servo, and the two values there are 30 and 80. We now got a bunch of different variables just to hold things. There's a position variable, there's a state variable, and then there's a handful of other variables as well. They're all just set as global variables. The whole thing just runs in one straight hit, so this is okay for us to do. First function, the setup function. We're going to set the serial port up. This allows us to write to the serial port and we can debug it on the comms. So we would go Tools, Serial Monitor up here. The next section is setting up the actual audio player. So first thing we do here is we try and initialize it. This is all very standard code. If you look up 𝗣𝗏𝗖 mini, you'll see all of this is an absolute standard piece of code. It checks to see if it's ready and it can communicate. If it can't, it's probably one of these two errors. It doesn't know which one. Recheck the connections or insert the SD card. If all is well, it will say it's online. We'll set the volume to 30, which is the maximum, and then we will move on. We will set up our light enable as an output, our limit switch as an input with a pull-up, and our PIR trigger as an input. And then we're also going to set up our two servo objects and going to attach them to D9 and D8 respectively. We're going to set the state of the thing to 0, print out what the actual project is called, and then just for debug we're going to just squirt out to the serial port all the various different servo, jump and other parameters, so you can see it when you start the thing up. Finally, we're going to actually move those two servos into their inactive positions. So we're going to put the ratchet servo into its back position and the jump servo into its back position. Now we've got the bread and butter of the code, the main loop. So this is going to loop, as it says, go over and over and over again. And what I've got here is something called a state machine. So a state machine allows you to maintain state, wait and do things in that state whilst waiting for other things to happen to jump into a different state. Think about traffic lights as a simple idea of a state machine. Red, amber and green. The red one you would go into, you would stay in there for a specific time, you'd jump to the amber, stay in for a little bit of time, jump to the green, stay in some more, go all the way back to red again. That's a very simple state machine which would just be decided upon a timer. Although traffic lights in cities these days are often more dynamic than that and can actually change on and off as required. So state 0, this is where we start out. This is the decision wait state. We print it out and then we're actually looking to see if the limit switch is closed. If it isn't, we know the switch is open, we're going to move to state 1. Otherwise, we're just going to stay here in this state. Once we're in this state, we know we've got to start winding it up. So we're going to print out a cycle variable, which we're going to increment. And then we've got a simple delay loop. So we're going to step all the way to, we're going to move the servo ratchet back, wait, move it forwards. We're turning a light on just for a flash, short delay, turn the light off, longer delay. Now you don't need the lights in here, you can do whatever else you want with the lights. This is just to basically briefly flash the light so you can see the thing is ratcheting. Now these two values here are things you can play with. These dictate how long you're going to wait for the servo to move in and out of position. These are 250 milliseconds each, so the whole thing will ratchet twice per second, which doesn't sound very fast, but actually is about the quickest this servo can go before it starts to miss out and miss steps. So we do all this, that's effectively one step of the ratchet. We increment a little pointer and then we're going to check. If it hits 49, in my position, if it's done 49 steps, it's probably already fully wound. And if you're already at that point, but you haven't hit the limit switch, which is what we check next, then I'm going to print that there's a winding error. We're going to come out of it and then we're going to exit ready to fire. That way, even if the thing misses a few steps, if it gets to 49, we're going to come out of here anyway. We're then going to state that the spring is compressed and reset our variable, wait a few seconds. I'm waiting 5 seconds before jumping into state 2. And then I'm basically waiting with the thing fully wound up, ready to fire. So I'm saying here, printing it out, waiting for trigger. If the PIR trigger is high, then we're going to say boom, we're ready to go. I'm turning the light on, I'm playing the MP3, I'm playing track number 2 off my SD card. You'll have to change that for whatever you've got on your SD card. Then I'm actually going to do the boom. I'm going to move the servo right into the out of the way position. Going to have a little wait, very important to let it move. Then I'm going to move the jump servo into the fire position. So what this does is it basically moves both those servos out of the way. Now the ratchet can freely spin and it's under massive tension with the spring, so all it can do is throw that central rod up in the air. It does it very quickly. I'm waiting for a second, then I'm moving that jump fire position it back into its regular state. I'm waiting again for 5 seconds and moving on to state 3. And it will do this until it gets that PIR. So it will look here. If there's no PIR trigger, it skips all of this code and goes back again. And it will just keep staying in this state until it hits the PIR trigger. So if there's something wrong with your PIR trigger and it never sees it, it will get stuck in this state. You will see on the comms port, you'll see this repeatedly written basically. Well, this wait for trigger will be repeatedly written. So now the thing's fired, we're actually going to do an extra check just to be sure it did fire, because by now the limit switch should have gone open again. It should have gone high again, because the central column that was pushing it down is now gone. In which case we're then going to say we're going to turn the light off and move back to state 0. And if it hasn't gone, then we actually can stay in this state and wait for it to work. And that is all the program is. It goes straight back to state 0, where it then starts looking for this limit switch again. And you'll see here, if it's still open, it will go into the winding stage where it starts winding it up. That's all there is to it in the software. So there's a few things you can adjust. You've got to adjust your servo positions. You've got to adjust, you probably want to adjust your MP3 player volume. And then the other things you want to adjust are in the actual servo driving, how long you want to wait in between the servos to make the servo go faster or slower, depending on which servo you've got. Other than that, code should work. It's been tested quite extensively. As long as you've got it all set up, you should be getting a nice repeated trigger and release. So last thing to do is a final test of the whole system. So plugging in a battery. This one's been used quite a bit, so it's running out of power. And you can't quite see it because it's out of shot, but we have we can put the nun's head up there. Let's do that. See? Oh, you can see her. Okay. So here she comes down. So it's having trouble with the last few cogs because the battery's a bit flat. Make sure you've got a strong battery. Anyway, it's now ready for triggering, so as soon as I move, off it goes. So a couple of things to note. It is quite noisy. I mean, that's just the nature of using servo motors. They've just got a lot of gearing in. They're just pretty noisy beasts. One thing we can do is build some sort of cover or around the thing. I mean, you may just use, you know, an upturned plastic box, or maybe you're going to be a little more adventurous and put some sort of wooden enclosure around it or something like that. And the other thing to note is that it doesn't have to be used vertically. We don't have to use this sort of prop vertically. Yeah, we can use it vertically to lift something up. We can also use it to shoot something sideways. So just to show you quickly the idea, I basically put a mummy's hand attached to the pole. You can see the thing is being winched back in, and it's not secured very well. It's secured with just a couple of twist ties at the moment. You'll get the idea of it anyway. And you can put anything you wanted here. You could have it a hand peeking out between a couple of gravestones, and when it's triggered it reaches out. That would be pretty frightening. And triggered. Out comes the hand. Pretty rapid. And that's only with one spring. This thing you could put two in parallel, but even faster response. You're going to need an even more beefy battery though. If you've managed to get all the way to the end of this video and you've watched all the videos in the series, thanks very much for watching. It took me a long time to put together, and I think it was hopefully worthwhile for you to see. If so, please like and subscribe, and I'll continue making more videos.